So we are starting our unit on rational functions. So rational just means fraction. So we are dealing with fractions. Rational functions are fractions. And these are the steps that we're going to take whenever we go through problems where we are simplifying rational expressions. Okay, so we're going to start off with the problems, and then I'll kind of walk you through these different steps. So, for example 1, the first step we need to make sure is that the problem is written as numerator over denominator, so it has to be written as a fraction, which with number 1 it already is. Descending order doesn't happen with something like this. This is one term over one term. It's a monomial over a monomial. So we've seen trinomials where they've got 3 terms. We've seen binomials where they have 2 terms. So this one's easy because it's just one term over one term. And then this one, we don't really factor monomials. We just reduce, kind of like you would if you had the fraction like 50 over 100. You'd be like, oh, 50 over 100 is 1/2. Or you would just take out what's in common. So if we look at this, if we have the fraction 18 over 24, you can do that in your head. You can say, oh, 18 and 24 both have 6 in common, or you can let the calculator do it for you. So I'm going to do alpha y equals to type this in as a fraction. Sorry, I'm trying to get the glare. And then I can type in 18 over 24. And when I type it in as a fraction like that, the calculator will automatically reduce it for me. So 3/4 is what it reduces to. So I'm going to write the fraction 3 over 4 like that. And then on the top, we have 3 x's. X to the third is 3 x's. On the bottom, we have 2 x's. And so an x on the top and an x on the bottom cancel. And we are left over with 1 x on the top. And so this is our answer. So some people show their work like this. Some people might say, oh, there's 2 x's on the bottom that would cancel with 2 of the x's on the top and leave 1 x left over on the top. Whichever way you do it is fine. Okay. Here's another example, example 2. So if we look at this example, it is written as numerator over denominator. We don't really have to worry about descending order because this one is actually already in factored form. So if we look at this, we can see that they've already factored it. It looks like they've taken a GCF out. So once you have something in factored form, what that means is that this is on the top, this is a multiplication problem. On the bottom, this is a multiplication problem because it's the GCF multiplied by the factor. It's the GCF multiplied by the factor. Fractions are division. So, and what do we know about multiplication and division? What do they do? Multiplication and division, what do they do? Or like, what do addition and subtraction do? Add 1 and subtract 1, or multiply by 5 and divide by 5. What do they do? Anybody know? Add and subtract, multiply and divide. How do they relate to each other? They cancel each other out. Yeah. So if this problem is written as multiplication and this problem is written as multiplication, then when the top and the bottom are divided, that means we can cancel them out. Right? So here, once we have the problem written in factored form, that means that if we see something that's the same, we can cancel it out because multiplication and division cancel each other out. So when I look here, I can see my parentheses are not the same. I have an x minus 1 and an x minus 2. Those are different. But I can see here I have an x and an x. So the 7 and the 3 are different, but the x and the x, those are the same. And then I've got 7 times x minus 1 and 3 times x minus 2. Okay, so let's look at the next one. This is the one where we really actually have to do some work. So if we look at example 3, I can see that it's written as like an actual division problem. They haven't written it as a fraction yet. So we have to go to step 1. We have to write this as a numerator over a denominator. So I'm going to write this as a fraction. So I'm going to have x squared plus 9x plus 20 on the top, and then on the bottom I'm going to have x squared plus 13x plus 40. Now in step 2, when it says to write the problem in descending order, it's talking about how, like this, if you have something that's out of order, we like to change it to be written correctly. So we know that when we write polynomials, we always put the x squared term first, then we put the x term, and then we put the constant on the end, or the plain number on the end. So if we look at this, this looks like a quadratic or your trinomial that we're pretty used to seeing. Okay, now some students will try to cancel x squared with x squared. They'll try to do that, and that does not work because this right here is an addition problem, and this right here is an addition problem, and addition and division do not cancel out. Does that make sense? Adding and dividing do not cancel out. So whenever you see somebody do this, they're killing a puppy. That's on the wall. Everyone see the puppy poster? It's a cute little golden retriever. I'll bring it around so you guys can see it. That's what we're killing, okay? Honors Math 3, when we did this unit with them, they killed like 1,000 puppies. I don't know. It was a whole bloodbath. So when we did, I'll have to show you guys, but there was one particular problem on the polynomials test where like none of you guys got it wrong. And on the honors test, I think it was like half of them got it wrong, but all of you guys got it right. So we're going to do better than them on killing the puppies. Sound good? You guys are not going to kill any puppies. What kills puppies? Canceling right here. This kills puppies. So what we have to do first, we can't cancel right now. We have to go on to step 3. We have to factor. Because we have to turn it into a multiplication first, because multiplication and division, that's what cancels. Addition and division don't cancel. Multiplication and division cancel. So what we have to do is we have to turn it into a multiplication problem. So we're going to look, and we're going to say, okay, for this top one, we have to find what multiplies to 20 but adds to 9. And for the bottom one, we have to find what multiplies to 40 but adds to 13. So multiplies to 20 but adds to 9. And then multiplies to 40 but adds to 13. Anyone? 5 and 4. Okay. Anyone know the other numbers? 5 and 8. Okay. So on the top, we're going to put x plus 5, x plus 4. And then on the bottom, we're going to put x plus 5, x plus 8. Okay. So now what we do is we look and we say, let's reduce the factors that are the same. So if we look in this problem, what do you guys see on top and bottom that is identical? The 5s. So x plus 5, those are the same. X plus 4 and X plus 8, those are not the same. Those are different. So our final answer is going to be X plus 4 over X plus 8. And we are done. That's it. Okay, let's flip it over. Yep. Let's see. I think I'm out of copy. I'm going to need to print one for you. So let me get through these notes. And then do you have your, you were here yesterday. Do you have the assignment from yesterday done? Okay. Let me get through these notes and then I will get it printed for you. All right, next example. So what do we have to do first? Is it written the way it should be? No. What do we have to do? Yeah, so this needs to be written in front, x cubed minus 6x. It's got to be written in the correct order. And then, what were you saying? We have to write it as a fraction. So x cubed minus 6x is going to go on top. And then on the bottom, x squared plus x. Okay? So we did the first step, we wrote it as a fraction. We also did the second step where we wrote it in the correct order. Fixed the order, wrote it as a fraction. Okay, now the third step says write it as the factored form. So, and we have all the different types of factoring that we've done. That first problem was the x thingy, right? We had a trinomial, so we were multiplying to the end term, adding to the middle term. This time we only have two binomials, which means we're going to be doing GCF. GCF or difference of squares, but these are both GCF problems. So if you look at the top, can you tell what the GCF is for the top? What's in common between the two? Anybody know? X. So we're going to take an X out, and then what's left over? We had 3, we took 1 out. 2 left over, so x squared, and then minus 6. Perfect. So we had 6x, we took the x out, so it left us with the 6. And then on the bottom, what's the GCF? Just the x. And then what's left over? We had 2 x's, we took 1 out, so that leaves x. Plus, we took the x out though, so what do we leave as a placeholder? Not 0, because we have to know that this times this would give us that. It has to be a 1. Perfect. Okay, so are the parentheses going to cancel out? Are the parentheses identical? The parentheses are not identical, so they won't cancel out. What would cancel out? The x's in the front. The GCFs are identical, so those are going to cancel out. So our final answer is going to be x squared minus 1. Sorry, x squared minus 6 over x plus 1. All right. Now, this next problem has, as far as factoring goes, probably the thing in this unit that's going to trip you up the most. It's not difficult. It's just easy for it to mess with you. Okay? So if we look at this, first step, is it written as a fraction? Second step, is it written in the correct order? Yes. Okay, so third step is where we start to factor it. And factoring the top is okay. The top has 2 terms. It is not a GCF this time. This time it's difference of squares. So if you guys remember, difference of squares is 2 sets of parentheses, one with a plus, one with a minus. So what should the top be? No. So we say for the x squared, it's going to be something and something. And then for the 16, it's going to be something and something. X plus 4, x minus 4. Perfect. Okay, now the bottom is the weird part. Okay, so this is the part that can throw you off. But the nice thing about this is that it's repetitive. So we will always do it the same way. Okay, so we're going to look over to the front of our paper. And I'm going to grab a different color of pen and make sure that I just circle this, highlight it, make it really stand out. If you have a negative in the front, you have to factor out a -1. You have to treat it like a GCF problem. And this is the part that will mess you up this unit. It's not difficult, but if you miss it, it will mess up the problem. Okay? So what we're going to do is we're going to go back to that part on the bottom, because if we were to do this right now, we would write -x plus 4, and we would say, oh, nothing cancels. Nothing's the same. We have an x plus 4 on the top, but we have a -x plus 4 on the bottom. We have an x minus 4 on the top, but we have a -x plus 4 on the bottom. Nothing would cancel. But if you do what the front of the paper says, if you take the problem and say, okay, I'm going to divide out a -1, -x divided by -1 is positive x. Positive 4 divided by -1 is -4. And what do you guys notice now if we took out a -1? You can cancel now. So if you forget that that's something we're supposed to do, then you'll think, you might get to a problem and think that the answer's not there if it's a multiple choice problem, or you might think nothing's going to cancel, and then you'd be wrong because you just didn't take the negative out. Okay? So x minus 4 and x minus 4, those are exactly the same. And so we could say that x plus 4 over -1 is the answer, but so this is right. You can say this and you're not wrong. But most people would not do that. Most people don't leave 1 on the bottom of a fraction. Most people would take each of these terms and they would divide it by a negative. So what is x divided by a negative? -x. And what is 4 divided by a negative? -4. Most people would choose the second answer, not the first. They're both the same. They're both accurate. But the second answer is the one that would probably be written down. Okay? Now, if you write the first answer on your paper, I would give you full credit. That's right. But the second answer is the one that would be, like if you had a multiple choice test, the second answer is the one that would be the multiple choice answer. Does that make sense? Okay. All right, let's try example 6. Okay. Step 1, is it written as a fraction, numerator over denominator? Yes. Is it written in descending order? No. So how should we fix it? Okay, x squared, and the x squared is positive, so I'm going to write it as a positive. Minus 4x minus 5, okay? That's 2x minus 15, okay? And then we can just cancel out our x squareds and cancel out these x's. Are we allowed to do that? No, that kills a puppy. Oh, thank you. Okay, so we can't kill puppies. Let's not do that. What should we do instead? Factor. So step 3 says, don't kill puppies, factor instead. And so we're finding what multiplies to -5, but adds to -4. And we are finding what multiplies to negative 15 and adds to negative 2. Negative 5 and 1. Negative 5 and 3. Isaiah, I hope you know none of us were even trying because we were just letting you do it. We were like, Isaiah's going to figure it out, so use our calculator this time. So we got x minus 5x plus 1. And then we got x minus 5x plus 3. And then what is identical? What cancels out? The x minus 5s are exactly the same. And then the x plus 1 and the x plus 3 are different, so they have to stay behind. So this is our answer. Okay, we're going to go back and do one little piece of the notes. This part right here in the middle. So it says an excluded value. An excluded value is a value that makes the expression undefined. Rational functions, so fractions are undefined when the denominator is a specific number. What number can the denominator not be? 0. The denominator of a fraction cannot be 0. That's a problem. So to find the excluded value of a rational expression, all of these were rational expressions, what you do is you look at the problem before you cancel anything out. So you're looking at the original problem and you see what x value gives you an error message in the calculator. So what we're going to do is we're going to go to y equals, and we're going to type these in. So 18x to the third, alpha, y equals. So 18x to the third over 24x squared. And then if you hit second graph, you can see that this one has an error message at 0. So 0 is the excluded value. If you plug 0 in for x, you won't be able to get an answer. The calculator is going to be like, nope, nope, nope. That's dividing by 0. We can't do that. So here we would say x cannot equal 0. Okay, for example 2, alpha y equals 7x x minus 1 over 3x x minus 2. We have 2 excluded values on this one. The excluded values are 0 and 2. Can't have 0, can't have 2. Can't have 0, can't have 2. X cannot equal 0, x cannot equal 2. Okay. If we look at example 3, now you can type this one in as a fraction if you want, or you can type it in the way they originally typed it. So I'm going to go ahead and type it the original way. X squared plus 9x plus 20 divided by x squared plus 13x plus 40. And this time we're going to have 2 We have an error at -5, and we have an error at -8. Anyone have a guess about where the error messages are coming from? Could you do it without graphing it? Okay, let's try some more. Eventually you'll be able to. Yeah, you can see it. So the excluded values, they come from before you cancel stuff out. You can get them on a calculator, but you can actually get them without a calculator too. Let's do some more. We'll see if you can figure it out. Okay, let's try this one. So I'm going to type this one in. I'll go ahead and type in the original problem. Divided by x squared plus x. Okay. So the error messages on this one are at 0 and -1. X cannot equal 0. X cannot equal -1. This next one, x squared minus 16 over -x plus 4. The error message is at +4. Anybody have any predictions about what the excluded values might be for number 6? So the excluded value for number 1 was 0. For number 2, it was 0 and 2. For number 3, it was -5 and -8. For number 4, it was 0 and -1. For number 5, it was 4. Let me finish the notes first. And then for number 6, it's going to be -3 is true, but 0 is not. -3 and another one. You're close. How'd you get the -3? Okay, so what would the other one be? So if it's a -3, the other one would be +5. So to find the excluded values, you always look at the factors on the bottom, even the ones that canceled, and it's just the opposite sign. So -3, +5. This one, +4. This one is -1. If you have a GCF that's an X, that's the one that's 0. So that's why number 6 didn't have 0, because it didn't have a GCF of X in the front. So 0, -1. Example 3 was -5, -8. This one was 0 and +2. This one is like a GCF, so that was 0. So you can do it with a calculator. You can see the error messages on the calculator, but you can also do it just by looking at it. But you have to look before you cancel. So you look when it's factored before you cancel. Okay, how do you guys' brains feel? Does that make sense? So what are we basically doing today? If we were to sum it up in like 2 words, what's like the very first thing we basically have to do? What's like the big step? If you don't do this, you're going to get it wrong. Factor. Factor, factor, cancel. If we were to break it down into 2 words today, factor, cancel. Does that make sense? Okay, so let me get you your worksheet, and we'll make sure we can. Is there anything on here? And you guys can go ahead. I don't need you guys to do the excluded values. You can ignore that. So you can ignore these directions. Okay. Are there any problems that you feel intimidated by? Anything you guys want to do together that feels like it could be weird? Number 12? Okay, so if we look at number 12, step 1 is to write it like a fraction. Step 2 is to make sure it's in the right order. We're not so much worried about order because in this one it's already factored for us. So if it's already factored, we just look at our parentheses, and what do we see about our parentheses? X plus 5s are identical. And then what's left over? Mm-hmm. So this section is just nice because they didn't make you factor. They already factored it for you. Mm-hmm. So you don't have to do the excluded values, but if you did, 7 and negative 5 would be the excluded values. Mm-hmm. Yep. Okay. Any other ones that feel intimidating? $20? Okay. So if we look at 20, we've got one with 2 terms and one with 3 terms. So we know the one with 3 terms is one of the X type of factoring. We know the one with the 2 terms is either going to be difference of squares or it's going to be GCF. So if we look at the problem already, it's written as a fraction. It's numerator over denominator. It goes in descending order. So we've got the b and then no b, we've got b squared, b and then no b, so the order's correct. So at this point, all we have to do is factor. So for the bottom, we're looking for what multiplies to 12 but adds to negative 7. And then for the top, we just got to find our GCF. So anyone know what multiplies to 12 but adds to negative 7? Okay. Negative 4, negative 3. And then on the top, we can do math, right, 9. Between 9 and 27, GCF is 9. So on the top, we're going to take out a 9. And then what's left over? Took out a 9, and we've got b minus 3, okay. And then on the bottom, we've got b minus 4, b minus 3. Okay. And then what is identical? The b minus 3s are identical, okay. And then the stuff that wasn't identical is left over, and that's your answer. Okay, we good? go ahead and work on that. I'll get your guys' test back.